We're going to look at one more problem, which is there is a student in this class who has been in every room of at least one building on campus. And the question here is use predicates, use quantifiers, use logical connections, and use these things to express the following statement mathematically. Okay, so first question is how many domains am I playing with here? Like, what are the number of domains here? So I have over here, I'm going to use a slightly darker color here. So let's say there is a student. There is a student, right? There is some student out there, which implies that I have a domain here. I have a domain of all students. Okay, so this is a domain of all students. And in this domain of all students, there's someone out here, such that who has been in every room, who has been in every room. Okay, again, I have the keyword every. That's telling you that if I have a domain of all rooms, right, this individual has been in every single room of at least one building, okay. Again, some kind of a quantifier of saying at least one building. So I have another domain here of all buildings. Okay, I have another domain of all buildings, and let's assume that we are right now restricting ourselves. Just for the sake of clarity, let's assume we're right now at Boston University, and at Boston University, these are all the buildings at BU. These are all the rooms. These are all the rooms at BU, and let's say these are all my students right now in this brown domain. Okay, so there is a student in this class. Now, how would I put this mathematically? There is a student in this class. There is some student. So meaning that this exists some x. Okay, let's call this student x over here. Okay, so there exists some x and there exists some y. Okay, so here the building, I'm looking at the building, and the building in this case is there is some y. In this entire universe of all buildings at BU, there is some y, such that for all the rooms, okay, so for all z, let's use the variable z here, such that for all z, something must hold true. Something must hold true. And we're going to say, I don't know what a something is right now, but let's just create a box here. And we're going to fill this box in a few moments, such that this orange box over here must be true for all z, and you're going to select some x and some y over here. Okay, so once I select some x, once I select some y, and for all z, this entire box is going to be true. Okay, let's introduce some predicates. Here. So I'm going to introduce the predicate p of z comma y, such that z is in y. That's what the predicate p means. The predicate q is x comma z, and what that implies is that x has been in z. Okay, and the way I'm going to complete this is I'm going to say that my hypothesis is p of z comma y. If this happens, then q of x comma z holds. That's my conclusion. Okay, let's try to understand what's happening here. So if I select some x, and this x over here, let's give it a name. Let's say this is Abbas here. Okay, and we're going to assume Abbas has been in every single room of some building on campus. Let's just assume that. Okay, so let's say this y over here, let's just give some names. The moment you give some names over here, I believe things become a little bit more clear, and we try to understand things a little bit more logically. So here's our CS building on campus, and these are all the rooms. These are all the rooms at BU. Keep in mind, these are not the rooms in the CAS building. These are all the rooms at BU, meaning somewhere over here, this portion over here in pink could be all the rooms in CAS, right? And likewise, some portion over here in pink could be all the rooms, could be all the rooms. I don't know. This could be the psych building, right? And likewise, you get the idea that this could be, let's say, the engineering building. These are all the rooms in the engineering building, right? This could be the engineering building. Okay. Now, what I'm proposing here is that my hypothesis is P of z comma y. Okay, what's z here? But z over here says for all z over here is basically my rooms, right? So let's just select some. Let's select some variable. Let's just make sure we don't skip the step here. So x is in this case is going to be Abbas. So x is going to be Abbas here, and there exists some y. And let's just make right now. Let's make this a CAS. Okay. Now, once you have selected your x and y, meaning your x over here is Abbas, and your y over here is the CAS building. Now you're going to go across every single room in BU. Okay, this pink box over here. Let's just make sure when will this pink box. Let's just concentrate on this pink box over here. Okay, so for every single z. So first thing, I'll go across every single z. Let's just start with this entire universe in yellow, and we need to go across every single room here. So I'm going to start with the blue first. Okay, so I start using the rooms in the psych building. Okay, so if z happens to be one of the rooms in the psych building, okay, this by predicate says z is in y. So let's say this is some room which happens to be in a psych building. It's obvious that z is not in y because I'm currently looking at some room in the psych building which does not happen to be in the CS. So what happens to your hypothesis? Well, your hypothesis is going to become false. It's going to become false here. If your hypothesis becomes false in the conditional statement, it doesn't matter what your conclusion is. The entire statement in orange is going to be true. Okay, which means it's going to be true for every single room in the psych building. And it's also going to be true for every single room in the engineering building. It's going to be true for every single room that does not happen to be in the CAS building. Just think about this. The CS building over here is in pink. Everything in pink over here are the rooms in the CAS building. But everything that is not in pink here, are rooms that are not in the CAS building, which means that the predicate P is going to be false for every single room. And when it is false for every single room that is not in the CS building, the conditional statement is going to be true. But we haven't yet traversed every single Z. Let's start looking at the rooms that are in this pink blurb here. So now I start selecting rooms in the CS building. So once I take one such pink room over here, okay, P of z comma y becomes true. At this point, this becomes true. When this becomes true, okay, again, super important, super important. Keep in mind, we've already made sure that the x and the y is fixed here. I'm not even changing my x and y right now. Okay, when this becomes true, the only time the conditional statement in orange will be true if your conclusion is also true. So what's the conclusion now? Well, the conclusion here is q of x comma z is x has been in z, meaning Abbas has been in this room in pink here. Z over here is a room that has been pulled from this pink blurb here. Well, my claim is that Abbas is one such student that has been on every single room in at least one building, which happens in the CS building. So meaning that conclusion is also going to be true, right? And it's going to be, your conclusion is always going to be true for every single one of these rooms in this pink blurb, which means that this entire orange statement is going to be true for every single Z. And you have found one student here, which happens to be Abbas here. But will this hold? Let's say if you were to start, let's say in this case I happen to have chosen Abbas and the CS building. What if you happen to choose somebody else here? Okay, let's say start somebody else over here, which happens to be, let's say, Jake. And Jake is one such person that hasn't been in every single room of at least one building on campus. So how are this thing going to work for Jake? If I started with Jake, would this entire logic, entire mathematical expression that I have communicated here, would it still be correct for Jake as well? Let's try this. So if I choose now X happens to be Jake here, and let's say the Y over here happens to be the CS building. Okay, we'll keep Y the same as it is. And now if I go, if I look at my predicate here, which is P of Z comma Y. Now, if I were to select and go across, let's say this entire let's start with the pink. Let's start with the pink portion over here. If I select every single room, okay, such that the predicate over here becomes true. Okay, so Z is a room that happens to be in the CS building, meaning this piece over here is going to be true. If this hypothesis becomes true, let's look at the conclusion. Well, the conclusion here is X has been in Z. Well, X over here is Jake. Jake has not been in this specific room on campus, which means that your conclusion becomes false. If this becomes false. Well, if this becomes false, the entire statement over here, which is in orange, is going to become false as well. Meaning that you have found one Z for which this entire statement becomes false, which will force you to select some other X and some other Y and then rerun it again for every single Z until you hit one such person, such as Abbas over here, who may have been on every single room on at least one building on campus.